Forget about market crashes for a second. Forget about complex code. Today, we're diving into a totally different kind of threat to Bitcoin. We're talking about a ticking political time bomb that might be literally impossible to defuse. And it threatens the very foundation of the entire network.
Okay, let's just jump right into this. I want you to imagine a giant threat is on the horizon, something that could completely shatter Bitcoin's security. Now, the crazy part is, the technical fix for it, it already exists. But, and this is a huge but, actually implementing it requires every single user, every developer, and every miner on the planet to agree on a massive, disruptive change, all at once, with absolutely no one in charge. This isn't a science problem, it's a human coordination failure just waiting to happen. So to really understand why this is such a uniquely difficult, almost impossible problem for a decentralized system like Bitcoin, we have to look at its history. You see, this is not the first time the community has faced a really contentious upgrade, and the scars from those past battles, well, they run deep.
Now, this slide really puts it all into perspective. Think back to the Y2K bug, right? It was this massive technical problem, but we solved it. Why? Because governments could step in and force companies to fix their code. Corporations had clear legal and financial reasons to get it done. Bitcoin has none of that. There is no CEO, there's no board of directors, there's no central authority to bang the gavel and make a decision. It relies completely on voluntary, messy, human consensus. It's basically organized chaos.
And here's Exhibit A for just how messy that can get. The last major upgrade Bitcoin went through, called SegWit, turned into a 3-year civil war. It was so bitter, so divisive, that it literally tore the community in two, leading to the creation of a whole new coin, Bitcoin Cash. Now, a quantum migration, that would be orders of magnitude more complex and way more disruptive than SegWit ever was. We're talking about changing the absolute core of how Bitcoin works.
So here's the really crucial point. We actually have the technical tools to fight off the quantum threat. Cryptographers have already developed several different post-quantum signature schemes. So what's the problem? Well, the problem is none of them are a perfect fit, not even close. Every single one comes with a very, very painful trade-off.
This table really lays out the dilemma. Just look at the options. You've got hash-based signatures like Sphinx Plus. They're super secure, but they make transactions enormous, which would bloat the blockchain to an unusable size. Then you have Lamport signatures. Again, highly secure, but the user experience is just awful. You'd have to use a brand new address for every single transaction you make. Imagine that. And finally, you've got this newer, lattice-based crypto. It's a really promising candidate, but adopting it would mean integrating a totally new and complex type of math into Bitcoin's very conservative codebase. There are just no easy answers here. This analogy just captures the problem perfectly, doesn't it? Choosing the most straightforward solution, something like SPHINCS Plus, is exactly like this. It's like replacing a quick, simple signature with a giant, cumbersome legal document for every single purchase you make. Yeah, it's more secure, but it makes the entire system slow, expensive, and just a total pain to use.
And this is the moment the technical problem explodes into a full-blown political crisis. Because any plan to migrate to new technology has to deal with the millions of Bitcoin that are just sitting there right now in vulnerable wallets. And many of them can probably never be moved. These are the billion-dollar hostages. First up, we've got an estimated 4 million Bitcoin. 4 million! They're all sitting in older wallets where the public key is just visible right there on the blockchain. That basically puts a giant target on their back for a quantum computer. Their owners, assuming they're even still alive or have the keys, would have to actively move those coins to a new safe address.
But then you have the most famous hostage of all. Over 1 million coins that belong to Bitcoin's creator, Satoshi Nakamoto. They haven't moved in over a decade. And they're all stored using an early, now extremely vulnerable wallet format. So any decision about what to do with lost or unmoved coins inevitably becomes a decision about what to do with Satoshi's coins. And that's a political landmine. And this brings us to the absolutely terrifying question at the heart of this whole crisis. What do? Do you force a migration, set a hard deadline, and basically say any unmoved, vulnerable coins are effectively burned or frozen forever? That could mean destroying billions, maybe tens of billions of dollars. Or do you just leave them there, creating a permanent, quantum vulnerable attack surface that could one day shatter everyone's trust in the entire system?
As if that wasn't enough pressure. All of this is happening under a ticking clock.
A quantum computer that can actually break modern encryption is no longer science fiction. It's an engineering problem with a deadline, and that deadline is getting closer and closer, whether Bitcoin is ready to have this debate or not.
Just take a look at this timeline. The tech work is already happening. But look at that last part. The brutal, inevitable political debate over how to actually turn this thing on is scheduled to happen right as the threat window opens. We will be arguing about the solution at the exact same moment the problem arrives. That is an unbelievably dangerous position to be in.
So really, this leaves us with two potential futures. The best case, a smooth, coordinated migration where the community somehow, miraculously, achieves consensus and preserves trust in the network. The worst case, political deadlock, inaction, and then one day the first quantum computer comes online. Vulnerable wallets start getting drained, and it causes a catastrophic, total collapse of trust in the entire 21 million coin supply. Ultimately, what this all comes down to is a really profound question. Bitcoin has survived market crashes, it survived exchange collapses, and it survived government crackdowns. But those were all external threats. This is an internal structural problem. And whether a leaderless, decentralized system can actually fix itself in the face of a true existential crisis, well, that's a question that has never been answered at this scale.